everybody. Welcome back to the Doctors In podcast. I'm your host, Dr. Nadia Saba. Today's interview is part of the series of episodes where I'm putting a spotlight on energy in controlled environment agriculture. My guest today is Dan Dettmers, Technical Regulatory Associate Director of Madison Air. It's a mouthful. Some of you may know him or perhaps have met him at a trade show representing Quest dehumidifiers. In fact, many would probably consider him the guru of standalone dehumidifiers. What you may not know is that he is also extremely prolific in the world of codes and standards. He's involved in everything from establishing new dehumidifier rating standards to navigating the rules of new HVAC refrigerants, which I think went into effect this year. He understands controlled environment agriculture really well and the challenges that we all are facing when it comes to managing humidity. He can always be counted on to advocate for our industry and for custom testing procedures and rating methods that actually apply to what we do in CEA rather than to homes in the residential market, which is where they were originally developed for. Because of his involvement and his extreme knowledge of how federal, state, and local regulations work, I thought he'd be the perfect person to educate us all on energy codes and standards that are seeping their way in slowly, in some places more quickly, into our industry. Whereas last episode, I focused more on the carrot approach to energy savings, you could say this week we are focusing more on the stick. Dan, it is so great to have you back on the Doctors In podcast. You are only one of a couple of guests that I've had on more than once. So thank you for doing that with me.
It was so much fun the first time that you, if I recall, you took the one podcast, turned into two podcasts.
We did, yeah.
But couldn't the second one be my first return? So I'm actually a third time return.
Oh, I like it. I like it.
Kind of like the Saturday Night Live 5-timers club. I want to get there.
You want to be the 3-timers club? All right.
I want
He's
you to
pulling
send me
ahead
a
like the
smoking.
camel race.
Yes. No, I want you to send me a smoking jacket with 5 on it.
A green one, right? Yes.
Heck yeah.
Well, the first question I have for you, Dan, is did you bring your stick with you? You gonna beat us over the head with
regulatory
it?
stick? I have a couple of curling brooms. They're just out of reach. I could get one of those if it would make you feel better.
Perfect. Okay. If you need to bring it out, feel free to
Right.
like whip me into shape here. So first off, can you just tell us what it is you do at Madison Air? That title is pretty intense.
I was gonna say, I was wondering why you were laughing while you're reading my title there.
I mean, that's like 5 words long or something.
I was told it took 4 HR people to come up with that title. So
each person got a word in there.
Yeah, exactly. Sort of like writing a song, so they each got writing credit. So they could get the royalties off of every time I say Technical Regulatory Associate Director. So the long story short is,
yes.
So I may have mentioned in the previous podcast. So my original line of work was mostly in ammonia refrigeration, right? So
okay,
big industrial food processing. And the unique thing about ammonia, well, not so unique anymore, is it's slightly flammable. It's also kind of toxic. Well, when all these new refrigerants were coming out, these new refrigerants are also slightly flammable, meaning it won't necessarily explode. It takes a lot of energy to get them started, to get them burning, but they will burn, right? So that means there's a lot more of the regulations that come along with it. Well, corporate started looking around and said, hey, wait a minute, how come this Madison plant is having such a easy time getting through the regulations and our other facilities are struggling? Well, it's because I was just using my knowledge from the ammonia industry, working with the Madison Fire Department and getting our building approved.
Nice.
Which, since no good deed goes unpunished, I got moved up to corporate and became the tech, yeah, I can't even remember. Okay, director, because director was the lowest title they had. Associate, because I said I don't want anybody reporting to me. And then regulatory, because that was the division they put me in, and technical, because basically I'm in charge of not only the refrigerant transition, which you're right, it was supposed to be done January 1st, 2025, but we'll talk about that more later.
Okay.
We're still moving along. And I also take care of codes and standards, especially in the CEA industry, hence why I'm here on your show.
Okay, I think I understand, and I think I understand why your background and experience is particularly, I don't know, useful to your company and to our industry. Um so I know there's a lot of movement right now in general when it comes to codes and standards, whether you are in CEA or any other industry in our country, in the US.
Yes. Both
We
forwards and back, and then forwards and then back. And I don't know. The pendulum swings very quickly these days.
It's so maddening. And so, of course, for our listeners, I want to try to keep it focused on CEA. I think that's what people are going to be interested in. But I think that there are other forces that probably are affecting what is happening in our industry and what codes and standards will be coming, have already been established, and what might end up being put on hold or slowed down or sped up. So, I know they're not mutually exclusive, but just as much as we can, try to stay on on CEA. So,
Well,
okay,
focus. If you can
focus. I
focus,
know.
I'll focus.
Otherwise, you're gonna be episode guest number 3 and 4. See, this is how
Exactly.
you get there. You play the game. You play the game, and you're not an incentives guy. Yeah. Okay. First off, let's just start with the basics. What are energy codes, standards, and regulations? Are they all one and the same? Are they a little bit different? And what are their ultimate goals?
Sure. I mean, yeah, we hear about regulations, we hear about codes, we hear about legislation, their standards. How do they all fit together? Well, I, boy, that's a really good question. And there is no one normal pattern for how they come to exist. Now, a lot of them start as what we would call standards. So those are developed by some outside industry, like, or usually an organization, ASHRAE. So what used to be the American Society Heating, Refrigeration, Air Conditioning Engineers. They establish all kinds of standards for energy use, for indoor air quality, for how to test equipment. And those standards all become, you've heard the phrase ANSI, right? ANSI standards. So that's another organization, the American National Standards Institute. So they're a they're the standards police, right? So when an ASHRAE or ASABE or Architects Institute of America, AIA, or the lighting guys, IEEE, want to put together a standard, they have to follow the ANSI process, which involves public input. So that's kind of the key to a really good ANSI standard. Is it's not just 5 or 6 people sitting in a room and going, we should make the lighting levels for CEA 27, 27 watts. I don't know. We'll come up with the units later, right? It might seem that way, but all of these standards should have a public review process so people like you and I and anyone listening to this podcast can jump in and say, I like what you're going with this, but let me suggest a change. And all those comments have to be resolved. And in the end, they come up with something that theoretically should work really well for the industry. So now that's the standard. But kind of the saying is the only people that enforce standards are lawyers, right? Just the standard by itself doesn't carry any weight unless a lawyer is suing another lawyer on behalf of a couple of different clients and they say, according to this ASHRAE standard, you should have done this. All right. So it doesn't carry a lot of weight by itself, but it then gets picked up usually by a building code, sometimes by legislation or regulation put out by a government agency. So building code is the most normal way, right? So there's various building codes, the International Building Code, the Uniform Mechanical Code. California has their own California Mechanical Code. Yeah, it's pretty unique and it's only used in California, but that's you people. Um, so once they adopt the standard, they might say, all right, you need to follow the efficiency requirements of ASHRAE standard 90.1, because that is the efficiency. Or they might say, you need to follow 90.1 except for, and they might list a couple of different variations, right? And this isn't just energy efficiency. This is for building safety, building construction, fire safety. So, for a while, the story goes that the Chicago building code adopted a certain building code, except for it had special restrictions about lanterns near cows because there was some little incident back in the 1800s where a cow burned down half of Chicago, right? So there's a lot of times local variations. And once that building code comes into effect, that could be at the state level, it could be even at the county or municipal level. And sometimes it's all three. The state takes it, then the municipality adopts the states, but makes a few changes. And then ultimately it's enforced by your building code inspector. So that either building code inspector or fire marshal or other, we call them AHJs, authority having jurisdiction, somebody who shows up when you've got your building plans all laid out and says, I like this, but I don't like this, right? This violates some building code, and then you have to make a change with your architect, engineer, or I don't know if you're doing it yourself with your eraser. And then ultimately, you have to meet all of the building code officials' demands for minimum requirements before they give you an occupancy permit and you can actually move in and start using the building. That's the typical route. The other route is once in a while legislatures, usually at the state level, will just straight up adopt a standard and make that the law, or there'll be Department of Workforce Development or Department of Environmental Conservation or Department of Natural Resources that might adopt some of these and implement those rules in their rulemaking. There's several different ways, but they generally start as standards. But again, not always. How's that for a non-answer? There's 1,000 different ways we can get these energy efficiency minimum levels enforced upon us or brought to us.
Right. I mean, I'm glad you brought up the legislature idea, because wasn't there some sneaky legislation that was put into Illinois' requirements for indoor
Yeah,
cannabis cultivation facilities?
yeah. So I mean, if you start looking at history, there's good and bad, right? So what? Okay, Washington and Colorado are what? 2012. Okay, I feel like do you have some bourbon or something? Because we should be doing a drunk history period.
I
There you go. There's
do.
show number 4 or 5. Drunk
You
history
want me to go
of
pull it out right now? I
yeah,
wish I could
drunk
just hand
history
it
of
to you through the camera.
CEA regulations. So 2012 was when I believe that's when recreational or
Yes,
whatever came
Washington and
legal.
Colorado. Yep, you got it.
And I think it was so Denver had the first regulation. I believe it was like 2017, 2018. It was the city of Denver and the county of Denver came out with basically minimum efficiencies on standalone dehumidifiers. And I mean, it was the first attempt at it, and then they kind of expanded it to include the whole facility. And it was pretty well thought out, especially given that, I mean, not a lot of people were thinking about it. But yeah, but then it was like 2019. I remember, I think it was June, because I remember it was kind of like a day like this. So up here in Wisconsin right now, it's rainy, cloudy, miserable spring day. And I remember my boss at the time brought me this legislation that was about to be passed in Illinois, and he said, "Quick read through this. We need some comments on it before the governor signs it. What do you think?"
Whoa.
I read through the thing, and within an hour, I produced such comments as they're requiring equipment that doesn't even exist. I'm not sure what intern wrote this, but even the state of Illinois agreed that, yeah, it probably wasn't the best thing. But by the time I got done and I walked in his office to hand to him, he looked at me, he goes, "Yeah, too late. The governor already signed it."
No way.
It went through their whole process lickety split so fast. Nobody had a chance to comment, and they were stuck with it. Now, you go to the other end of the spectrum, and probably about that same time, somewhere in 2018, is when California started looking at it for Title 24.
Mm-hmm.
Well, they didn't come out with their first energy code until what? It was Energy Code 2022,
Yep.
which in California logic means it didn't become effective until 2023. So
Correct.
I don't understand you people, but
They
I
still
mean,
got to edit it. I don't know.
I don't know.
Last
Like
minute comments.
2022 effective in 2023, 2025 effective in 2026. Like, what
Yep.
is wrong with you people? But you know, that was a long drawn out process that went through a lot of public scrutiny and a lot of great input, and they built a really, really good program. But then some lawyers got a hold of it the last minute and changed some of it. But well, okay, we recovered.
Yeah.
So it's all good now.
That's the thing when making laws, right? I mean, regulate a regulation is ultimately a law, right? And so it's going to require some lawyers to review it for legalese and to make sure it doesn't probably conflict with other sections or
Oh yeah.
whatever. Yeah. So,
And there's always, you've got the legislation itself, the regulation, and then there's the interpretation and implementation. So
oh
that
yeah,
becomes a whole nother office with their own views on, I know they wrote this, but what they really meant was this.
exactly.
And things get really, really crazy.
Yeah.
My favorite
Yeah.
example of that was Washington State, where that was more of their refrigerant phase out. They wanted a sticker to show it was approved for Washington State, and another sticker to prove something else. It ended up. I was like, wait, our unit's gonna look like a NASCAR, right? Race car. They're gonna be just full of stickers. They're not gonna be room to actually see the unit itself. But that's when the department went, oh yeah, maybe we don't need all that.
Yeah, I mean, one of the sticking points in the California Energy Code for CEA for greenhouses specifically is that the line says, if you are a conditioned greenhouse, then you have to meet these certain requirements. And so we were getting a lot of questions, what is a conditioned greenhouse?
Right.
And I'm like, great question. I don't know. What is a conditioned greenhouse, right? And so I went back to the Energy Commission and I said, hey, you guys, like, what is the definition of a conditioned greenhouse? People are trying to figure out if they, if their projects apply to that, or if they don't, or if there's a way around it, or if these other systems maybe are exempt from it, right? Because there's not really a lot of exemptions yet in our energy code for controlled environment ag. And so they finally said, oh, well, if you go all the way back to the beginning
Yep.
of the energy code under definitions, that conditioned greenhouse is means 50 BTUs per square foot of heating. And that is, and I was like, well, where did that number come from? And they said, well, we don't, we needed a number. Right, a limit. Uh-huh.
There
And
it
they said,
is.
so we based it off of commercial buildings.
Yep.
And I'm like, oh, okay. I mean, at least it's something, but that is something, by the way, listeners, right? Like, does 50 BTUs per square foot of heating make sense to you? Are you providing that much, more, less, right? Because maybe there's an exemption there. And same with cooling, right? Like the cooling side, there wasn't really a cooling number or value to it, but it was just that it's air conditioned, right? An air
Right.
conditioner is being used. But then that brings up questions for me. Well, is it dehumidifier air conditioning? Right? I
Space
exactly. Right. I
conditioning.
mean, there's so many like questions that can follow one answer leads sometimes to
Yep.
another question, right?
And that's absolutely what happened with the dehumidifiers. At the last minute, the lawyers came along and said, "Wait a minute, we don't like the definitions you put in for dehumidifier and the energy efficiency levels because there's this federal regulation." Well, the
Mhm.
federal regulation was for consumer products, right? Residential dehumidifiers, but they said, "Nope, you implement that." Well, that's all well and good, but the Quest salesman felt kind of funny going, all right, well, it looks like you're installing a whole home dehumidifier. So you're going to have to meet these regulations of these standards. And people are like, I don't want a whole home dehumidifier in my cannabis operation. Like, no, no, we would never sell this 500 pint per day unit to a home, but that's what it's classified as because of the rules that were adopted. Yeah, we'll get that fixed by Energy Code 2028, maybe, which will be implemented in 2029.
2029, yeah.
So
And
just
then the
hang
meteor
on.
will strike us and it'll be all over. So
We're getting there. We're getting there. It'll be fixed.
um okay. So okay, we generally have an idea of code standards regulations. So um why do you think CEA, or in California, we call it Controlled Environment Horticulture, as to not confuse it with the California Energy Alliance, by the way. If anyone wanted to know why the energy code is for Controlled Environment Horticulture, is because CEA was already taken. Um, dumb. So just call
But
it
hey,
CEA 2 or CEA Mini or CEA some, I don't know.
I personally like it because if somebody calls me and starts talking about CEH, I'm like, oh, it's one of those California
It's a
names.
California person.
If it's CEA or indoor garden or anything like that, then I know it's
The
someone from
other 49 states and the rest of the world.
right.
We like to be different. What can I say, Dan? So, I mean, from your perspective, from your point of view and your experience, why do you think CEA or CEH has come under such scrutiny and kind of under the microscope when it comes to energy efficiency?
Right. I mean, ultimately, we're trying to make the world a better place by growing vegetables local and whatnot. But regulators got to regulate. Politicians got to politic, right? They need to do
Interesting.
something too. And I've thought about this one, on many a different occasions. Like, why do they pick on us? Why can't we just be left alone? Um, really, I mean, the first one is the truly massive energy use. And now, okay, in engineering, right, we always say you got to draw your boundaries, right? So where are we drawing our boundary lines to look at inputs and outputs and what's happening? So if you look at just the energy use of an indoor, I mean, if we were growing strawberries in a completely enclosed artificial light space, man, that's using a lot more energy to grow that strawberry, right? The electricity, the space conditioning, the water, everything that we're bringing in, than a strawberry that's just being grown in the field. But if that strawberry is being grown in Madison, Wisconsin, and it's being shipped all of like a half a mile to my grocery store, and then I drive a half a mile to pick it up, maybe if we expand that energy use boundary out to look at what did it take to transport it, to refrigerate it, to store it, to create the plastic cartons, to create everything, we have to look at the bigger picture, but that's too hard. Politicians like nice, clean, tiny things that we can draw little boundaries around and then make, you know, 10-second sound bites out for the politics. So that's part of it. I mean, but it is valid, right? This kind of started again. I think the Denver one came about because about 2018, what was it? If I remember, it was like 4 to 5% of the energy use in Denver was going
That's
to
right.
cannabis, right?
Yeah,
And
that's
so
nuts.
Denver went, oh, and about the same time, I think it was like a year later, Ontario did a study, and because all of a sudden they noticed power lines were sagging, right? Well, why do power lines sag? Because so much electricity is going through it that it's heating up, and the whole thing kind of starts dipping
That's a
and
thing?
stretching. Oh yeah, that's how your a lot of your wildfires started there with PG&E. When it gets hot out and everybody's turning on their air conditioners, all that power goes through there, that heats up, and metal sags when it expands when it gets warm. So Ontario was
I
seeing,
had no idea.
yep, and they were like,
Wow.
we got to do something about this. So they did an energy study and figured out, well, all these people were building their cannabis operations in Canada and Ontario at the end of the power distribution line. So they were sending massive amounts of electricity far, far away. So
Wow.
that was,
Wow.
and even now, Jeff Kelly, I can't
Yep.
recall. Have you had Jeff on yet?
I'm gonna have him on. We're gonna talk about energy modeling.
He is you're gonna love him. So he is one of the best energy modelers I've seen. Well, he looked at Missouri, right? The state of Missouri when they came online and did some models and figured out how much energy was being used. And what was the number? He said it was the equivalent of building 325 or something, somewhere around that number, new grocery stores. And he's like, if you're a
Wow.
politician, if you're a utility, if you're, your state regulator for electricity, and all of a sudden 325 superstore Walmarts pop up, you're going to notice and you're going to want to do something about, hey, wait a minute, let's make sure we're using the least amount of energy. So it's that
Interesting.
massive energy use and how quickly it comes online that gets the attention of politicians and everyone. And then the other part, I mean, let's be honest, the food industry, it's heavily regulated and subsidized now. I mean, you've got
Mm.
the FDA, the USDA, all these farm subsidies. I mean, how often, it's what, every 3 years we get a new Farm Bill 2018, Farm Bill 2022, um, that are providing subsidies. And sometimes it's to stop growing an agricultural commodity like tobacco, or it's to start growing or grow more of a particular thing that we're in need of, or
Like hemp, for example.
hemp,
Yep.
or it's to spread it out, right? So
Yeah.
for example, I think it's still the case that dairy subsidies are based on your distance from Eau Claire, Wisconsin. So Eau Claire, Wisconsin
Really?
is point zero, and this is the way it was established in the 30s, because at that point that was considered the focal point of all the dairy industry. So basically, they got no subsidies, and by the time you got to California or Vermont or Florida, you were getting maximum subsidies. And
Interesting.
they still use that, but they'll now use like a multi-subsidy point and multi-base point model to spread out the money or whatever. But it's basically to push agricultural productions to areas where it isn't. And this is just commonplace in the food industry. So, to
Yeah.
regulate indoor agriculture, it just seems a natural thing to do.
Right, right. I mean, something that I find encouraging and that or as like a silver lining maybe, is that if politicians, if regulators are paying attention to our industry, then they believe that this is legitimate
Yep.
and that it has a future, right? That it's not just a flash in the pan, it's something that's going to come and go, that it's a trend, right? And so to me that actually feels legitimizing for our industry, is that look, other people are looking at what we're doing and saying this is sticking around. We need to put some guardrails on it.
That that is a beautiful feel-good way of taking a horrible thing and making you feel so happy about it.
I know. Leave it to me to
Oh,
find the silver lining, but I did.
oh, Nadia, I'm so glad that people that know nothing about growing strawberries are telling me how to grow strawberries. And people that know nothing about lighting are telling me how much light I can put on my
I
lettuce.
know.
I feel so much better.
I didn't say they're
Oh,
doing it correctly. They just know that we're sticking around and they want to do
okay.
something.
Wow, maybe could you edit that last little bit out? That might not play so well the next time I'm sitting in front of some state senator. Oh yeah,
uh,
Dan, I saw this one video of you. Oh gosh. I'll leave
we'll
it in.
make
I
sure
don't
we
care.
promote the heck out of this so that people know that you made that comment.
Yeah, right there you go.
And me too, I guess. Take it
Well,
however
that's
you
it. I
want.
guess I'm never running for public office now. Oh,
I'll still support you, Dan.
all right.
One thing I also you were talking about Denver, and it was around 2018 that we got a call. I got a call from a grower, cannabis grower, who was building a greenhouse or trying to build a greenhouse in Boulder. And he's like out in the sticks near like a compost facility and a hog farm and all kinds of things. And people were complaining that it was going to smell, right? The cannabis
Yeah.
odors, they were complaining about the potential cannabis odors. And so he's like, they're forcing us to, mitigate odor. And the best way we can really think of is to air condition the greenhouse, right? To seal it up and prevent any odors, any air to escape the greenhouse. But we still want to be in a greenhouse because we want to take advantage of natural sunlight, blah, blah, blah. And so he's like, so, I got a quote, or, I like calculated it out, and they're estimating it's gonna cost like 2 or 3 million dollars for my little like 20,000 square foot greenhouse. And And I remember, I mean, this is early. I think I was still on my own. I was still a sole prop at this time. And I'm sitting on my front porch. I'm like, well, just give me a second. Like, okay, how big is it? What canopy, right? Sunlight. And I'm just kind of like back of the envelope, literally, on the back of a piece of paper, just calculating it out. And I'm like, yeah, just based on the solar heat gain, right? And at the time, multiply, I don't know, 2 or 3 thousand dollars per ton. Yeah, this is easily $2 to $3 million. And he was just like, "Are you fucking serious?" And I'm like, "Yeah." And I actually wrote to the city of Boulder after doing that little exercise, and I said, "Do you realize that your odor control ordinance is actually forcing cannabis growers who want to do it the right way, who want to take advantage of your amazing, dry, sunny climate, is forcing them indoors, right, in air conditioning where they're just going to gobble up all this energy?" And I got an email response back a week later, and they're like, "Oh, we didn't think about that." And that
Mhm.
was literally the end of it. And and it's just like talking about, right, how like sometimes regulations and codes can actually conflict with themselves, right? And it's like, okay, so odor seems like a good idea, but then what are the consequences on the energy side?
Yep.
you know um and I don't think they realize that. I mean, I have visited that greenhouse since it was built. It is air conditioned. I don't smell a lot of odor, but I still look around and there's still farms that surround this greenhouse, and I'm it's just like, why? Like, why?
And Boulder wasn't the only place like that. There were so many
Yeah.
municipalities that wanted to push that out to the edge of town for the odor, for the um, societal benefits, right? Oh, we don't want to admit that there might be marijuana growing in the area, so let's put it way out there. And it was at the end of the line, and so they weren't thinking about what it costs to build a facility, what it costs to get the power there. So early on, we would get calls for gas-fired desiccant units to dehumidify these units, and I was like, that's the least efficient dehumidification technology you could pick under most circumstances. Why do you want that? They're like, because it's gas fired. So we don't use as much electricity because we're already tapped out on electricity. Like, okay, I understand. I understand. So now, I mean, there's new ways of rezoning, bringing in it closer, getting it the power you need, and controlling that odor. I mean, I've seen new ways coming up all the time of either filtering it or ozone or ions or something to knock the odor out before it goes out and potentially annoys the neighbor. And I mean, and if nothing else, you can just get a really big fan and shoot it straight up in the atmosphere.
Exactly. It's true. I mean,
It
that's what we do
is.
in labs, right? In hospitals. I mean,
Exactly.
yeah, you just shoot all that contaminated air up into the stratosphere. And by the time it dissipates, it's lost all of its smell and it's reacted with ozone and whatever.
I visited a farm like that. It was in downtown Los Angeles. I mean, you got to the neighborhood and you're like, it's around here somewhere. But obviously, they didn't want anybody in the neighborhood to know exactly where, so that's why they shot it up. And from the outside front, you couldn't tell that was a grow
It
operation.
worked.
It worked. It worked
That's
really
amazing.
well.
Yeah, yeah. We've not to digress too far, but we have been
Oh, we're already way too far.
yeah, we've put together several odor mitigation plans, and many of them have been in New England and the
Mhm.
Northeast, where all the little townships and communities, right, that are very concerned about the smell, or maybe they just don't want cannabis, right? It's just one of those easy things to point your finger at, I think, because one, it's hard to deny that they're this, right? Like, how do you do like there are traffic studies that people do to demonstrate, like, oh, this really isn't going to cause any more traffic, right? I know that's a big one as well. Or you're concerned about light pollution with the lights being on at night, so they're install blackout curtains, right, to prevent that. And that's not even necessarily cannabis. And so, but odor is so hard to measure and control that it's like the one thing that is hard to wiggle your way out of. So yeah, we've been called several times to help put together plans and help talk to these townships and city councils, and we've been successful, but it's tough, and you have to add so many more devices, right? So many more power consuming
Yeah,
devices that
exactly.
were not part of the original intent, and all of those add up, having 4 or 5 or 6 recirculating carbon filter and fan units, right, per room on top of other devices, like it all adds up, right? It all eats up
It
amps and it
does.
all uses power.
So I mean, that's why a lot of times air quality and energy efficiency are kind of at odds.
Yeah,
I mean, within ASHRAE, they've got standard 62, which is indoor air quality, and standard 90.1, which is energy efficiency, and they're button heads all the time.
yeah.
And we're starting to see the same thing in our industry here with CEA of not just thing the odors going out, but protecting the workers that are on the inside as well.
Absolutely. Absolutely. And carbon dioxide, right? I mean, I don't think it's technically classified as a contaminant, but we do know that it affects people's cognitive ability. And at the same time, it affects plants' growth. And so, right, like there's always going to be a push and pull
Right.
when it comes to even just that one constituent.
That was a big conversation. There's one of the things you're going to see coming up in the industry, just to step away from energy efficiency, is air quality regulation and worker protection. Um,
Hmm.
oh, I, I'm trying not to get into current politics, we'll say, with the current administration,
Yeah.
but up until January 19th, there was a big push towards protection of heat stress for workers, not just in the CEA industry, but all throughout. Um,
Yeah.
both heat stress and cold stress on the other end. So I know there was a committee formed by UL, the same UL sticker that you see on your refrigerator. They create other standards, and one of them was standard. Let's see, it was 4402. Wait, I've got it somewhere. Oh, indoor air quality in buildings and facilities utilized for the cultivation, production, and processing of cannabis.
Really?
It exists now. It's out there, to my knowledge, it hasn't been picked up in whole by any building code or mechanical code or anything like that, but bits and pieces are starting to be used. And there's also some in the fire code. So
Yeah.
NFPA's fire code, I think it's chapter 38 in NFPA 70, that talks about, again, for cannabis facilities, because part of it came about from, if you recall, oh, late 2021, 2022, there was a lot of explosions where people were trying to do the extraction using butane, and didn't do it so safe. So that came about from that fire codes, and then the air quality came about from, I guess, some building code inspector walked in with a meter and went, "Wait, you're at 2,000 parts per million. We all have to evacuate right now." The
Wow.
guy's like, "Well, no, this is a flower room. We keep it at 2,000 parts per million for the plant growth."
Yeah, yeah,
Yeah, so I mean, I remember Andy Souza was on that one, and there
yeah.
was a whole bunch of back and forth of, how do we protect the workers, but still, I mean, we need to produce plants, and that's part of plant production, and that's part of effective plant production. So I thought that one handled it pretty well as far as limiting ventilation and mostly doing it when lights are off and the CO2 enrichment wasn't going to be up there, but at the same time providing protections for the workers. So if CO2 got above a certain level, lights would turn on, alarms on the outside, so somebody walking in would realize, okay, I'm walking into this
Mhm.
CO2 rich environment, and I should be aware that I'm going to feel a little groggy and whatnot.
Yeah, yeah. I
I,
mean, it's one of the reasons why we always design ventilation into our HVAC systems, or recommend it for to manufacturers to include as part, because so many manufacturers, they were trying to meet the needs very rapidly of this industry as it was booming. And right, I mean, so many of them just turned outside air units into 100% recirculating air units
yeah,
without any addition of outside air into these spaces. And I pushed on a lot of them for a while, like I want access to outside air. Still want to be able to ventilate, even if that's not the normal operating procedure, right? Like there still should be a way of having being able to ventilate. And if nothing else, for let's just forget the people, let's talk about the plants, right? That's how I could
right,
sell it to the grower. It's like
right.
your CO2 enrichment system went down. Now all of a sudden it's
Now
200 parts per million, 165 parts per million in the room. Do you think your
what?
plants are growing? Wouldn't it be better to just open the outside air vent and just let, 400, let the room rise to ambient levels? And like you could just see kind of their wheels turn like, oh, yeah, I didn't even think that I could run out of CO2 or a solenoid valve could like stick closed or whatever. And, but for people, it's one of the standard operating procedures that we really recommend is look under, when nobody's in the room, yeah, just recirculate the air if that's what you want to do. If you're so afraid of outside air, which I think is nonsense. But when people are in the room, let's just make sure that we can ventilate, right?
Yeah,
That we can just like and by the way, trickling in, a little bit of air to the room probably isn't going to drop it all the way to ambient. There's still people working in the room, so it might actually still be like 600 or 700 parts per million. That's still elevated above ambient levels. You're still getting more yield than if you were down at 400 or, God forbid, 165, which we have seen in rooms that had no CO2 enrichment and just
wow.
recirculating air systems. And like, we don't understand why our plants aren't growing. And I was like, well, you're starving them, literally.
Right. How much would
Yeah.
how much would you grow at about 15% oxygen content
Yeah,
in the air,
exactly.
right?
Exactly.
Nada.
But it does take a little bit more energy, right? Like to bring us back to energy is that ventilating now means that we're not just conditioning, right? And processing room air. Now we're processing whatever the outside air conditions are, which could be, in Florida, could be 100 degrees and 90% relative humidity, right? That's going to take more energy to dehumidify and cool that than just 80 degrees and 70% humidity. And where you're at, right? I mean, it probably gets to 0 degrees, right? And
Keep
super
going.
bone dry, right? And
There's
so
days
how
where
do
it gets
they
up
heat
to
that
zero
air?
degrees. There's whole days where it only gets up to 0 degrees.
Oh
I
my
mean,
God. Okay. Well, that's why I don't live in Madison, Wisconsin.
I
Uh,
know those are the
yeah.
days I'm out on the lake ice fishing because I'm not going to be inside when it's so cold inside.
But yeah, so I mean there is an energy penalty to doing that, right?
So
But there also could be an energy benefit, right? I mean if we could convince growers to invest in air site economizers to do some of the dehumidification during the shoulder seasons when the conditions are right outside, they're not using compressors at all. They're just
yep,
using fans.
you have air side economizing. You have various forms of energy recovery, whether
Yep.
it's what we'll call a wraparound loop. So you've got
Mhm.
two coils with water flowing back and forth, or a heat pipe, same thing but with refrigerant, so you can capture air that capture either the heat or the cold from the air you're exhausting and put it in the incoming airstream. There's energy recovery wheels as well. Either they're made out of metal or they might be coated with a desiccant material. The key thing though is that I always tell everybody with those and anything else is make sure when you're done with your grow cycle or even maybe in between, clean them out, right?
Mm.
Anything,
Yeah.
I mean, those coils are often designed to not only capture heat but water. So now you've got a constantly wet surface. You've got a drain pan that's going to be wet. You got a drain line. Make sure you clean those out because those harbor so many things that so many pathogens that can grow in them. And we want to make sure that you're not transferring your problems from one crop to your next grow cycle crop, because that is another area there where regulation is starting to look at. Um, Checking the purity, I mean, not just the purity of the product, but looking for pathogens in the final product, in the raw product, and in the room that it's grown. So
Yeah.
keep ahead of
Yeah.
that.
And by the way, you didn't even mention hot gas reheat, which is probably the one maybe most people are familiar with. Which I learned in California. I just learned this recently. I was at a local growers event and they said that anytime if a unit comes with hot gas reheat, that now they just call it, the lingo is, do you have reheat? So they don't even say like package DX, integrated package, blah, 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 right? Like all these big terms, pool unit, that we
Right.
like to use. They just say, do you use reheat? And that is to them like the code, the lingo, the vocabulary for a unit with hot gas reheat.
I can't tell you how close my head is to exploding at the moment. I mean, this is a little off base, but it is very pertinent because this is where a lot of the energy use comes from in CEA, right? I
Yeah.
mean, cooling, yeah, we want to cool, but a lot of times we can tolerate 85 degrees depending upon what the crop is. But that humidity, whew, I mean, if it's 60 degrees and you hit what 85%, you got botrytis, right? Poof,
Yeah. Yeah.
if it's too hot and too humid, same thing, the plants are going to shut down. And so a lot of it goes into dehumidification. And honestly, other than desiccants, which, that's kind of a whole different technology, what we're really doing is we're giving it a cold surface. So so the air comes across that cold surface. That surface is cold enough to get the water to drop out. But now we've got this cold air, right? I'm talking like 55, 50, maybe even colder than that. Well, we sure don't want to put that on our plants. And even if we introduce it up top, now we're introducing really, really, really cold air, and you might be overcooling your space. So we need to heat that back up or reheat, right?
Yes.
So now that reheat, yeah, that's a phrase that's kind of thrown around a little too liberally.
Mm-hmm.
If you're talking about a standalone dehumidifier such as the Quest product, I mean that's reheat, and it's actually doing the same thing as those packaged rooftop units with a hot gas reheat. It's simply taking all the energy you took out at the evaporator and putting it into the condenser to put that heat back in the air.
Mm.
The difference is your standalone dehumidifier, that's what it was originally designed to do. So it does it really, really well. Packaged rooftop unit, I mean, that's kind of put in as an afterthought or maybe designed in, but it's still its primary purpose is to air condition. So it doesn't quite do that reheat as efficiently. And then there's other ways of doing it. I mean, you can keep on going to the worst is probably using electric resistance.
Oh,
So, you know, from the standpoint of control, I will admit electric resistance is awesome because you can turn that on and dial it up
yes.
and dial it down and off in an instant. So you can really control that leaving temperature, do exactly what you want. But your meter, wait, what? Do you hear that? Is that a helicopter? Oh no, that's my electric meter spinning out back, right? Because now I'm using a whole bunch of electricity to pull all that heat out of the air,
Yeah.
and I'm using even more electricity to put the heat right back in. Just doesn't make sense. Why not use the heat you already pulled out and put that same heat back in?
Yeah.
Reuse that. Reuse that reheat.
Which is why California included in their energy code that 75% of your reheat energy
Yep.
has to come from heat recovery. And so I don't think it's going to be in the next cycle, but most likely the next cycle,
Yeah.
they're talking about increasing that to 90%. And they're like, well, I mean, if it's already
Oh, and
75%, like, aren't they really just getting 90% anyway? And in California, that's probably true. But I mean, let me just ask you this question. For somewhere that's as cold as where you live, can and let's say we are ventilating just a little bit, minimum code ventilation rates,
mhm.
based maybe even on a square footage basis for a grow room. Do you think that we can hit 90 or 100% heat
Oh,
recovery during the dehumidification process, even when it's sub-zero temperatures outside?
absolutely. But again, it's dependent upon the technology you use, right?
Okay.
So if you're using a standalone dehumidifier, you have no choice. You're getting about 105 to 115% of the heat back because
Mm-hmm.
not only are you taking all the energy that you took out of the air, but also the energy, the compressor motor, the fan motor, that's all going back into that air and it's adding heat to your space, which, okay, when the lights are on, that's not desirable. But honestly, you're really dehumidification is for when the lights are out, right? When the lights are on, your air conditioning is doing most of your dehumidification. With the large packaged rooftop units where that hot gas reheat coil is put in, some of them struggle to get much above 60%. And that's partially from the design because you have to manage your oil, right? So
Uh-huh.
there's oil mixed in with the refrigerant, and so some of it has to go outside. A little bit of that heat has to be rejected outside. So you might have a hard time getting much above 90, or you might have gone cheap on the original construction and you only put half the amount of condenser into the indoor airstream as what you wanted, and so you're only going to get 50,
Hmm.
60%. It's the design. Other ones like your I don't want to call it, well, the swimming pool dehumidifiers, right? That that have been heavily modified. So Desert Air and Agronomics IQ. In those cases, they usually have a way of modulating the amount of heat. So either they're heating up a water glycol mixture, or they're sending again hot gas, but modulating the amount of hot gas so you can modulate the temperature leaving that. So if you want 100%, you get 100%. If you only want 80% because you don't want to warm your air up, you modulate back. If you need a little bit more, you modulate to get 105, 110%, whatever heat's available. And I will tell you, expect to see more and more of that. If you noticed, I was giving you the thumbs
Yeah,
up.
yeah.
Yeah, I wasn't necessarily just agreeing with you. I'm telling you, hey, hang on, I this now you're right. I didn't do a lot of homework, but I did pull this up. So there was a recently an addendum passed for 90.1 for swimming pool dehumidifiers, right? So very similar, right? You know, you think about swimming pools, what are they? It's a room with a great big source of moisture in it, right? So
Yeah.
very similar to indoor grow operation, whether you're talking lettuce, cannabis, whatever, I don't care. Um, I'm trying to find the exact. Okay, I guess I didn't do my homework that well because I don't have it right
You
here.
didn't set yourself up well.
I did. I should have done like an extra minute and a half of homework apparently instead of taking the time to throw my dog out of here so it wouldn't
Oh.
interfere with this podcast. Okay, so it was if you want to look it up, it was proposed addendum AJ to 90.1. This was done last year, and in it, let's see, there's a specific section on dehumidification energy recovery, and it says that if you are using mechanically cooled indoor pool dehumidifiers, they shall be capable and configured to use condenser heat to heat the pool water or the natatorium air, right? So imagine
Okay.
us saying that exact same thing, except for we're saying for heating the air inside of a CEA operate or CEH operation. I'll start using your lingo. Um, but then it goes on and it says other equipment for heating the indoor pool, water, or air, or for this natatorium space heating shall not be used until 100% of the available condenser heat rejection has been used. So
Okay.
basically, until you've taken all that, so if you've got something that's pulling the water out of the air and cooling that air down, all that heat has to go right back into the space before you can turn on a furnace, before you can turn on electric resistance, before you can turn on some sort of a heat pump to bring heat on. The only thing you could do is, well, solar, right? Solar's free energy, so you could use that. Um, and I would predict with nearly 100% certainty that wording just like this is being developed for ASHRAE 90.1 and possibly even California. Obviously not this upcoming 2025 energy code, but yeah, the
Yeah.
2028 beyond. Um,
I mean, that actually makes sense. I feel like that should be the intent of the code, right? Is to use as much as you've got and then use an auxiliary
right,
heating system, not use the auxiliary heating system first and then
exactly.
your heat recovery. Uh so I like the intent
Yep.
of that law or of that code, that
And
standard, that
now
language.
what I will throw in there is for those of you who love electric resistance heat for that ultimate control,
Yeah.
it doesn't say you can't use that. It doesn't say you can't use electric heat. You just have to use all that condenser heat first. And so theoretically, especially when the lights are out and there's a low air conditioning load, well, you're going to be running that, you're going to be using all that heat, and you're still going to probably need a little bit more heat
Yeah.
because of the cooling from the plants, because of any cold from the outdoors that's coming in. So you can still use that electric resistance to give you the fine control you need. It's just going to be a tiny amount instead of the whole amount, right?
Right.
using it logically.
Sometimes I think you had mentioned a while ago about, using electric heat versus, say, a furnace to do the heating. And, in California and New York, and I know a few other places, right? Like, we're intensely looking at walking back all combustion based heating, right? And
Mhm.
and rely solely on electrical. I'm going to try not to digress down that path, but I will say that I love my gas stove. And so, because I like the precision, by the way, of heating
Okay.
and turning things on and off when I want them to.
But can I just suggest,
But
have
it
you
makes
looked at?
me, but this is like one of those places where I feel like there's some conflict. It's like, well, don't use electric auxiliary heating, but also, by the way, you can't use a furnace because we don't allow combustion heating anymore. So, I just see something getting sorted out with that in the future, I guess.
There is. I mean, that's the decarbonization movement, right?
Yeah.
That's
Yeah.
that's the phrase. And you know, okay, so living up here in Wisconsin, I'm like, you're telling me that I can't take gas and put it in my 97% efficient furnace
Right.
my house. Instead, you'd rather have it be burned at a gas turbine at 35, 40% efficiency and the electricity come to my house. But the key there is I'm not using electric resistance to heat my house now. I'm using a heat pump, right? And a heat
Fair.
pump is an
Yes.
air conditioner that essentially runs backwards, right? I'm taking heat out of the outdoors and putting it in my house. The problem here in Wisconsin is, yeah, when we hit that week in January to early February where it never gets above 0 degrees Fahrenheit, Fahrenheit, not Celsius,
Yeah.
it's Fahrenheit, there's not a lot of heat out there to grab a hold of and bring on inside. So it doesn't work so well here. But you get to southern Illinois and south, now it starts to really, really make sense. But the technology is improving. We'll get there.
Yeah. I mean, I think that's a good segue into the tea leaves sort of question that I have for you.
Oh,
Which
do I need
is,
my crystal ball? Hang on.
yes, you do. Didn't you have one earlier? Where'd
No.
the colorful one go?
Oh yeah. Oh,
That
don't
is
make me
like the
plug it back
perfect
in.
crystal ball.
All right,
You
all
had
right.
no idea how perfect of a prop that was going to be for this podcast.
Okay,
There
here
it
we go.
is.
I've got my. So this is supposed to be lights that I want to put on the bookshelf behind me, but I haven't got my get around to it. Let me see
Okay,
if
so
I
if
can get the
anyone needs
colors to
their
oscillate a little
palm
bit.
read
All
or
right.
their tea leaves read, which that's what we're gonna do right now, Dan Dettmers is your man. Okay, so tea leaves question: What do you see coming with energy codes and standards in the next 3 to 5 years?
Okay. So uh, let me do the easy one first. Here's what
Okay,
I don't see coming. Anything more with lighting. I
thank
mean,
the gods.
I I think unless we come up with some yet newer technology than LEDs, I don't know. I've heard rumors of, I don't know, some sort of plasma, or I don't know. Unless something comes out that is even more efficient than LED, I think we're kind of done there, right?
We've about hit our limit on
Yeah,
efficiency with LEDs.
right.
Yeah.
Now, of course, what does that do? That pushes it back on the HVAC.
Hmm.
So I can tell you, California for the 2028 energy code, they are heavily focusing on air conditioning and dehumidification. Well, meanwhile, with the butting of heads, there's others focusing on indoor air quality. So you're going to see some pushback there of, that's really great efficient technology, but what about the air quality for the people inside? What about the air quality for the people outside? But you're definitely going to see pushes towards more efficient air conditioning, more efficient dehumidification, and more regulations. Really, I mean, air conditioning is pretty well regulated by the building industry, right? And honestly, for the most part, we're trying to hit somewhere between 70 and 80 degrees, which is, that's about what the rest of us are doing for our houses. So we're kind of taking care of there. The problem is with air conditioning, if you look at the way the ratings go, it's all based on how much temperature do I decrease, or how much heat can I remove for the amount of energy. But it's not total heat, it's sensible heat, right? It's the stuff that
Mm-hmm.
affects the temperature, not latent. So if you're an air conditioning manufacturer, what do? You take your air conditioning equipment and you make it so that coil stays hopefully above the dew point. So I'm only taking out sensible heat, not any latent, which works really well for most residential and commercial office buildings. It doesn't work so well for CEA. So now the focus comes back on dehumidification. How are you going to get that? So, you know, besides the aforementioned, what I just talked about with possibly using 100% of the condenser reheat, um, there's other movements afoot within AHRI. So that's the Manufacturers Association. So all those of us who manufacture space conditioning equipment, we belong to AHRI. And the natural progression is ASHRAE comes up with a standard for testing equipment. Then it goes over to AHRI, and AHRI kind of decides on the standard for what temperature and dew points and other conditions and CFM of air need to come into the unit and out of the unit in order to create a test standard. So now we've got the test conditions. Now I could go back to ASHRAE, and ASHRAE says, based on those test conditions, this is the minimum efficiency you need to achieve. Or it might be DOE, depending upon who's monitoring that piece of equipment. So when you start looking at dehumidification, though, all right, there's a really good standard for consumer product, residential dehumidifiers. What I predict is you're going to see that expand up into the commercial and agricultural world. So you're going to see some sort of standard developer standalone dehumidifiers. Likewise, you're going to see more test conditions being established for a dehumidification efficiency for other pieces of equipment, like air conditioners, like DOAS units, so dedicated outdoor air systems, which are often taken and just like you said before, Nadia, just recirculating the air. So we're not actually bringing in outside air, but they're really good. They're like a rooftop unit that's really good at dehumidifying. They have a slightly colder coil, so it pulls out more moisture. You're going to see more test standards and efficiency for like chilled water systems or built up systems. And once you start seeing those test standards and test conditions come out, well, then it's really easy for California, Washington, New York, and maybe even ASHRAE itself to say, all right, at those conditions, this is the minimum dehumidification efficiency we expect for use in CEA. And then from there, I'm sure it'll go to swimming pools and everything else as well. So that's like probably the biggest thing I see in the next 3 to 5 years. But wait, hold on, I have to change my color here. Let me find my controls. There's more.
That was good.
Well, thank you. It's almost like I practiced that not. So, okay, so like I said, there is going to be more on worker protection, air quality, plant protection as well. I mean, you see Oregon testing everything and anything. I think you're going to see that propagate to other states, and that falls back to the cleanliness of your grow operation. But the final one that I'm starting to see more and more is water reuse, right? So,
Yes.
and this is the one that gets me. Up in New England, where there's lots of water, they're all about grabbing that condensate, cleaning it, polishing it, and reusing it. But when I say something to someone from Denver or Arizona or Nevada or any of the dry states, I'm like, what are you doing with that water? Well, it goes down the drain. Like, no,
I know.
gotta reuse that. And they're like, oh, I never thought of that. I mean, okay, that's not everybody out there. And
Right.
honestly, that was more the attitude about 3 years ago. But now people are starting to pick up on it. And just like you mentioned before, the politicians must think it's a good thing because they're starting to look into regulating it and figuring it out. How are we going to do this? How are we going to capture this water and reuse it? Because, there's another industry that's maybe kind of beating us out at our own game on both water use and energy use. It's called data centers.
Mm.
So I mean, you remember 4, 5, 6 years ago, you and I, we'd give these talks at ASHRAE or someplace else, and walking along, and I'd hear, "Hey, pod guy," and I'm like, "Hey."
Yep.
Yeah, I mean,
Oh, you're
and
the cannabis girl.
that's
Like, I
right.
guess.
Dr. Greenhouse, is it? I mean, it was the thing. Everybody wanted in on it because that was the big growth industry. Not so much anymore.
Yeah.
Data centers have kind of eclipsed uh, indoor ag as like it's the new it thing. and partially because the amount of energy they use compared to
Mm,
us, whew, they're even blowing
yeah.
us out of the water. And the amount of water they use, same thing. So at Quest and our sister companies, we're actually getting inquiries from both the data industry and CEA to use basically dehumidifiers, not for dehumidification, but as atmospheric water generation,
Are you
right?
serious?
Oh yeah, oh yeah. This is like
Wow.
going on all over. I mean, we're looking into places like islands like Hawaii, Guam, Caribbean, places where on one side of the island you have a lot of humidity because of the prevailing winds, but on the other side where they want to grow the crops, there's just no water. So grab the water here, send it there. Using
Wow.
it just to generate water on site for these data centers to use for their cooling loops and everything because they have to evaporate so much. So,
Interesting.
marketing's loving this because, a dehumidifier is something that produces dry air and the water is a byproduct. Now we're producing water with dry air as the byproduct, I guess, right?
Yeah,
But
yeah. That's so
yeah,
interesting.
it's
I'm
one of those markets that we're like, wow, I never really saw that coming.
I mean, for me, coming from agriculture as an agricultural engineer by education, water has always been right. I mean, that is what farmers talk about, right? They talk about pests and disease. They talk, like okay, climate, but water, right? Like water quality, water
Yeah.
sources, and especially being here in California, doing my PhD in Arizona. I mean, water is just on everybody's mind all the time.
Oh yes.
And, I have always had sort of the opinion that energy is going to work itself out, right? We're going to go to more renewables. I mean, we have more energy from the sun in what, like a square mile than we need in the entire world. I don't think that's quite right, but it's something really dramatic like that. Um, we're just choosing not to capitalize on it. But it's there, right? Like, but, and that is a renewable resource. But water is not, right? It is a finite resource. And that is the issue I really feel any agricultural endeavor should be taking on and working harder to reduce. And it kind of surprises me sometimes when I look at California and it's like, why is it, the Energy Commission that is really plugged in to CEA or CEH and
Yeah.
not the Water Board, right?
Right.
Like, and the
Right.
Agriculture Commission, like they're the ones who should be looking at this as an opportunity to either regulate or rein in or promote CEH as a water conserving farming endeavor, but they're
Absolutely.
not. And I'm just like, there's a missed opportunity for our industry to do a better job and promote what we're really doing, not just make these lofty claims that we're going to recycle 95% of water and then you never do. Forget those people. Let's
Right.
actually do it and then say, look, this is how much we really saved. Okay, it's really 75 or 80% because we used reverse osmosis and had to do some cleaning or whatever. But that's a lot better
Right.
than all
Then
that
0%.
runoff just eroding our streams and polluting our aquifers, right? Like it's just like there's a huge opportunity there that our industry is missing, and the fact that data centers are doing that before us is a
Yeah.
travesty. It's really disappointing.
They all I can say is they have the money, right?
Yeah. Farmers don't have a lot of money. Yeah,
No.
I know. I know.
Like growing up as a dairy farmer kid, yeah, I
Yeah.
absolutely the two questions that always came up: when's it gonna rain, and when is the bank bill due?
Yeah, exactly. Um yeah, but I also wanted to ask a question about efficiency standards for dehumidifiers.
Hmm.
What will it be based on, right? So when we look at traditional HVAC equipment, you even made the comment, it's how much electricity do we put in to remove a unit of heat, right? Like so it's heat removal versus energy or electricity input. For a dehumidifier, is it the same efficiency equation or are we looking at different units?
It's again, well, let's draw our box, right? What are we drawing
Okay.
the box around? So if we look at just the unit, We're looking at just the dehumidifier. We're looking at just the packaged rooftop with reheat. We're looking at just the AgIQ desert air. You know what California calls integrated HVAC with hot gas reheat, right? The traditional way of looking at it is truly how much water are you removing over how much energy does it take, right? Pints per kilowatt hour is usually, or liters per kilowatt hour is what we're typically looking at, with different ways of measuring it for different pieces of equipment. But ultimately, that's what we're looking at. Now, that's because we need to keep things simple in order to fit into regulations, right? Because that's kind of missing a little bit of the bigger picture. So if I look at my standalone dehumidifier and hey, my Quest dehumidifier is at 9.5 pints per kilowatt hour. That's freaking awesome. Whereas these other technologies are at 4 pints per kilowatt hour, 3 pints per, maybe 1 pint per kilowatt hour, right? Maybe even less if it's, electric resistance. Okay, but let's take a step back and look at the bigger picture. Um, like I said, that standalone dehumidifier will be adding some heat to the space. Is that a good thing or a bad thing? Well, it depends. Is it when the lights are on and I don't need that heat? Or is it when the lights are off and I need that heat?
Yeah.
That's where 90.1 says, let's take a bigger looks at the whole building, right? Let's look at not just the prescriptive energy requirement for the unit, but let's take a look at the whole building. And basically when you have Jeff Kelly on and he starts talking about energy modeling, this is the only conversation you're going to be having. How does those systems fit together? How does that standalone dehumidifier go together with your split system air conditioning, with your packaged rooftop unit, with whatever you're doing for air conditioning? How does that chilled water system function to provide both heating and cooling and dehumidification? How does a built up system, that somebody jerry rigged out of pipe and compressors and other things that seem to have fallen off of a truck but somehow work? Sometimes those are honestly the best systems if you find the best person to put them together. Few and far between, but it does happen. I mean, that's the world I came from. It's really looking at the whole system. Am I using standalone dehumidifiers to do my dehumidification when I need a little extra heat? Then that makes perfect sense. Otherwise, I might want to look at a different technology, or how much of my energy am I getting from solar versus other sources of heat? Looking at your whole, taking a holistic view of your whole building and all the energy consumption. I mean, that's really where the industry's headed and where we want to be, so we can optimize our entire growth cycle for both energy efficiency and production, right? Because the most energy efficient thing I can do is turn them all off, right?
Yeah. Yeah.
But
Right.
then my plants die.
Yeah.
So
That
mm,
doesn't work.
no, right.
Yeah. Hey,
There has
Dawn,
to be a happy medium.
I mean, I know one of the very first questions I have to ask Jeff about is like, how do we establish a baseline? Right. I mean, that's probably an hour-long conversation in and of itself.
Easily. Easily.
Um,
Don't
uh,
ask me that one, please.
it's a scary question. Nobody will just make a freaking decision. Because I mean, but also there's so many different ways to do things for different crops and different facility types and blah blah blah. Like, how do we just decide? And I know that ASHRAE 98.1, when they have, right, when you're modeling different HVAC. Or you're modeling your building, you say what climate zone you're in, you say what type of occupancy or building classification it is, right? And then there's like this kind of like this tree, like this chart of, well, under this capacity or this load and in this location, this is the baseline. And, under this different capacity or load and location, it's this other system. And so we just need to put the brain trust together, not just ASHRAE and California's Energy Commission, but growers to say, hey, like everyone in New England is doing this. So that's going to be their baseline, right? Or
Right. Right.
everyone in Illinois was forced to do this. So that's now their baseline or
Use an
whatever. Like
imaginary
it just,
system, you mean?
but it's just so hard, right? To like just herd these cats. And I know I'm preaching to the choir when I say that, but it really is. But something that dawned on me about energy efficiency, you mentioned also earlier that most HVAC equipment, right, is rated on sensible energy, right? Like that's the goal, is to lower the temperature, right?
Right.
To lower the sensible.
Because
energy
that's
where
what the thermostat shows me, and that's what I'm shooting for.
exactly how many of our thermostats at home show what the humidity is? Like very few. But with dehumidifiers, we're saying liters per watt, for
Mhm.
example, but that liter is actually latent energy.
Right.
Right. So it's like, so traditional conventional HVAC is sensible energy, and dehumidifiers or dehumidification is latent energy. And we are separating the two in terms of efficiency ratings. And so I kind of wonder like what the trade-off can be, right? Where it's like, okay, we're going to say that a dehumidifier has to remove a minimum of, I don't know, what did you say? 500 pints or 9 liters per kilowatt or something or
Sure.
watt.
Yeah.
Well, yeah, I don't remember what the number was. Um, uh,
Let's go with 8 pints per kilowatt hour. How about
8 watts per kilowatt hour. Okay, so that's our energy efficiency target or goal or I don't know, requirement. So let's say that your dehumidifier does a better job at that, right? Let's say it's 10. Do you think that there could be an exception then or a derating of the efficiency that we would need from the air conditioner, its EER rating, if say the what's the equivalent of EER?
Well, it could be kilowatt per ton, EER, SEER for the efficiency of the air conditioner. There's a few
Right. So I'm just
different.
saying like if
Yeah.
if your dehumidifier can do the bulk of like the cooling and dehumidification, but you still need this other amount of cooling
Hmm.
that's that has a lower efficiency rating because of the conditions we're operating at or because it's a lower relative humidity and temperature. But oh, but this other piece of equipment is doing the heavy lift over here. This air conditioner doesn't have to work as hard, but it's going to have only a 7.6 EER as opposed to an 11. Do you think that there could
There,
be some trade-off there?
there in many areas there is, and
Okay.
now, okay, this is the thing is with CEA, not all municipalities, not all states are applying the code the same to it, right? Some
Yeah.
some are ignoring it completely. Some are like California and coming down on it, but really only at the time of construction. Um, right. So, but a lot of times, both in ASHRAE 90.1 and other energy codes that exist out there are allowances like that, where, all right, if you're doing much better over here, we'll let you do a little worse over here. And I guess the best way to explain it, let's go back to, I was talking about heat pumps, right? So up here in Wisconsin, where it's bitter cold, the bare minimum efficiency on a furnace, I think it's like 93, 94% for what you can put in. Like you can't put in an 80% efficient furnace unless, right, there's a caveat. Well, if you're going to put an air source heat pump, you're going to need some backup form of heat. Well, that might be electric resistance, but they'd rather you put in a furnace. And in that case, all right, you can go ahead and put in an 80% efficient furnace because it's a lot cheaper than that 97% efficient furnace,
Oh.
but you're only going to run it for a little bit. So the trade off becomes overall, you're doing better with this system for the dollars that you invested to the energy that you're using, right?
Yep.
And will the CEH industry get there? Absolutely, but it's going to take some time, and part of that is going back to that baseline. How much energy do we really use? Gosh, most of us have no idea. And even though, and some of us do, but only for this farm. And
Right.
this guy operates his operation different, so we don't know what it is for him versus this one. So it's establishing some sort of communal knowledge on how much energy it should take to grow a strawberry, to grow a pile of lettuce, to grow cannabis, to grow a tomato, and then going forward from there, and like you said, regionalizing it, because man, it's going to take a lot less energy in San Diego where the weather's always perfect versus growing a tomato in January in Wisconsin. That's a pretty expensive tomato.
Versus growing one in the summer in Florida, right? I
Right.
mean, yeah, so regionally diverse we are in the US that we need to be paying attention to that, which is why it's like it's great that California has an energy code, and we've been able to successfully push back on some measures that were proposed that were like, look, that's not applicable in California. Like triple pane glass, like why? What are we insulating against in California? Like
Right.
I that doesn't make any sense. Like maybe it makes more sense in Wisconsin, but still it's going to be cost prohibitive, by the way. But that's one of the things that I'm a little concerned about with ASHRAE is that if they just pick up California's energy code and they don't, pay attention to how our energy code that's very regional could impact other regions, then it's not going to be the right fit. And even like just sticking with the envelope, it's like, okay, well, in California, we have certain R values for an insulated building, but I bet it's a lot different than where you live.
Oh, very much so.
Yeah,
And that's where the beauty of going back to that ANSI organization again, right? The standards organization that says all you other organizations, this is how you will run your standard writing process. It's a requirement for that public review process. So even if ASHRAE just went to California and said, hey, we like what you got, we're going to steal that and then put it out there, that there's still an opportunity for each and every single one of us, not just here in the US, not just in North America, but around the world, to comment and say, hey, that works really well for California, but it doesn't work in Canada. It doesn't
hmm,
work in Abu Dhabi. It doesn't work in Chile. We would
yeah,
like to see this. And that's why, you see this gradual progression of codes and standards and whatnot. It starts out small, it really starts out regional, but they always grow over time to be more inclusive, to gather more data, to work better in more regions. But the bad part is it's a slow process. So a lot of
yeah,
times, whatever you see that comes out first, it's like my family going to Culver's for dinner. If I said we're all eating the same thing, then there's a guarantee that, well, none of us would be happy. I mean, I might be happy with what I have to eat, but I'm not happy with my kids complaining about what they have to eat.
right.
It's the same
Yep,
thing. If
yep.
if we say this is what it shall be, and there was no public input, nobody's going to be happy. But over time, we'll get there. We'll figure it out. I hope it just happens before I retire, or not that much longer after.
And and on that, I mean, on that note, I have been impressed with California and how it has been open to public feedback, to stakeholder feedback, and having open public meetings and webinars to explain, like, this is what we're thinking of doing. Tell us why you love it or hate it, why it's feasible or cost prohibitive, right? And so they really have done a good job over the last 5 or so years, trying to solicit that feedback. I know that people may have learned about it afterwards and wish that they were part of it. Just so
Right.
everybody knows, listening here, there is going to be another stakeholder meeting for California's energy code coming up in July, late July or early August. I already told them don't make it during the week of Cultivate. Everyone's going to be busy. So it'll be after that. So we can all talk about what it is we want and don't want before we all show up at that meeting. So Dan, I wanted to ask you, you're the stick, as I mentioned at the beginning, and we had the carrot. I just kind of wanted to get your thoughts in terms of the carrot versus stick approach, and which like, what are the pros and cons? You think one is more effective than the other at achieving this goal of reducing energy use?
It really has to be a combination of both. You know, it's the stick is there to get the lowest ones up to the minimum. The carrot's there to get the upper ones a little higher, a little better, right? And we need both of that. You know, nobody likes being told what to do, right? That goes back to when you're 2 years old and your mom says something, and what's usually like one of the first three words kids learn is no, right? And that's probably the biggest word in your vocabulary until you're, I don't know, 20, 23, trying to figure out. I guess
Forever.
no, not through the teenage years. My kids don't say no; they just go whatever. Like, okay, fine, I get it. That's the new no. Um, but by putting in these minimum regulations, and that's really what they are. They're minimums, right? And you always want to shoot for a little bit above it, because if I am running at minimum, that means if one thing breaks, if one thing fails, if one thing falls out of compliance, I am now below the minimum and I might be in some sort of trouble. But it basically kind of becomes this, like, let's call it a free design guide for the industry, right? And I kind of had a lot of fun. This industry, I mean, come on, we started it out as a black market, right? And even now there's a lot of legacy growers that maybe aren't following all the rules. So it was really great when I'd be talking to state legislatures, whether it was California or New York or Washington, and they're like, we're going to make them do this, we're going to make them do that. And I'm like, you realize 80% of the growers originally were afraid of getting thrown in prison for what they were doing. Now, what would they get? A fine? Yeah, they don't care. They'll just go black market. And then, whoa, wait a minute. Okay, so let's back up and rethink this. And so it was a really quick way to manage expectations of those bureaucrats, right? But in doing so, even for those legacy growers that are still out there, maybe not following all the rules, the rules are there. The local HVAC community understands them. They start to understand why these minimums are there, and how it's going to help you. And so that kind of becomes the baseline for the whole industry. Whether we're talking Michigan or Oklahoma or wherever these rules are being passed. And in the end, I mean, you got to think, you're in this business to make money, right? Because you can only go so long without making money before, well, you got bills to pay. And by doing this, it gives you a really good idea of, okay, if I do this, I'm at some base level efficiency that should put me on par with the rest of my competitors. So it really gets everyone to that point, hopefully without hitting too many people with the stick. But on the other end of the spectrum, I mean, the carrots are utility rebates, our increased production, better quality, right? All those things go into making a better product that's hopefully more profitable for you, either because you cut your energy consumption dollars, or you're getting more for your end product. And I tell you, I work just as much with people on the carrot side as I do with this on the stick side. I just, the stick side, it takes a little bit longer to beat into them where they should use the stick. Boy, there was too many analogies in that one.
I thought that was really interesting the way that you described that, though, that the stick is to set a minimum standard and the carrot is intended to push the people who are already doing the minimum to do better. I like that idea. And I mean, I think in general, right? Usually the carrot is tried before the stick, right? We try to dangle the benefits
Yep.
before we push them with the or else's, I guess.
Right. Hey, come on. Again, go back to your childhood. My mom would always first start with, if you do this, we can go to McDonald's.
Yeah,
And then it was later on, if you don't do this, I'm talking to your father when we get home. Like,
exactly,
okay,
exactly.
if the
And
carrot
so,
don't work, I love
it's also a question of psychology, right? Is like what people are more motivated by being encouraged to do something, and how many people are more motivated to do something because they have to do it.
and honestly, the stick works with more than, I mean, just the audience, right? The audience is going to be mostly growers. It works with us manufacturers as well, right?
Oh,
It gives
sure.
us it gives us that minimum bar to hit with our equipment. Um, and I mean, it keeps it as a pretty level playing field. I mean, let's be honest, there's a lot of equipment made overseas that maybe isn't quite the same efficiency level as what's being produced here in the US. Well, it forces them to come up to the same level, so
Mm.
nice even playing field, and the customer is getting what they expect, right?
That's interesting. I also wish that there was more promotion of the good. And I know we kind of joked about it earlier with the silver lining, But where, for those of you who might have come from the building industry, the LEED and green building design, they really got a foothold by demonstrating the economic benefits of efficiency, of reducing resource utilization, of creating a healthy work and living environment, of sourcing things more locally, and all of that. And they did a really good job, though, of putting a dollar value to it to show the economic add value of that system. And it was always voluntary, but now, even 25, 30 years later, some of that has gotten codified. And as people have become more familiar and comfortable and established their own design and building practices around something that was really aspirational
Yes.
25 or 30 years ago, now has become codified in a lot of places, like here in California with Cal Green. But it really took hold because there was an economic benefit to those developers, building owners, etc. And so I wish that we would talk about that more, to growers. That, I know growers are about growing things, right? We want
Right.
to grow more, and we want to sell more and make more, etc. But also, that other side of the efficiency and profitability equation is less. And if we could make a stronger argument that, look, these energy codes and these carrots are really there to help you save money, by reducing your resource utilization, that's another way to economic viability and growth.
Yeah. For example, you should look into the carrots being offered for induction cooktops instead of gas stoves. Oh, oh, wait. We weren't going to go there.
I'm not sold. I have to like change out like my
Oh,
my pots and pans. I mean, come on. I mean, actually,
well, it's
that's true.
okay
Can I use cast
because
iron on an induction stove?
um,
Yeah,
might
see.
actually be able to. Yeah, I
Oh,
think it's
okay, okay,
aeromagnetic.
okay.
You might be good on that one. Just not your aluminum pots
Not
and.
aluminum. Yeah.
But hey, induction cooktops, they are being pushed by the Energy Star program, which
You know what? I
probably
just
a lot
thought
of
of
people.
something. That could be part of the incentive, is if you switch to induction heating, it will come with a new set of pots and pans.
If only the Energy Star program makes it through the next 90 days and doesn't get cut.
Oh yeah. Now, Energy
Oh,
Star, what's that? That's going away.
right,
EPA, that's
right.
that's
Wait a
organization
minute.
that
Wait a
has.
minute. We weren't going to talk about
No, we
politics.
weren't. Okay, all right, all right.
Oh, I'm sorry
Okay,
I brought this up. I'm sorry. I'm sorry.
okay,
I'm
Dan.
sorry. But you're
Last
absolutely right.
question.
More
Okay, you ready?
carrots, less sticks.
More carrots and less sticks.
Yeah, and I mean, there's other carrots out there beyond rebates. I mean, some of the things that I know both ASHRAE and California are looking at, such things as commissioning of this of your building and your systems. Now,
You
when you
consider
think
that a
about this,
carrot?
I consider it's both a stick and a carrot. I mean, what's the purpose of commissioning? Is you're hiring an outside agent to sit down with you in the beginning to say, what is the purpose of this facility? What are the conditions I want to hit? Help you work with, if you're the business owner working with your master grower and trying to nail down like what temperature and relative humidity set points are you going to actually want? So that way
Mhm.
our equipment can be designed to work most
Exactly.
efficiently at those conditions. And then going through and as it's being built, making sure that the equipment you bought and you're installing is actually working the way the manufacturer said it was going to work. And then when your building is ready to go, making sure that your building actually operates the way it was supposed to operate. And then in some cases, even sticking around for the first year or two to help you work out the bugs that might have still crept into the design or the installation. I mean, this is
Yeah.
something that's required in the building industry, and it's something that California looked at. If you remember the case studies or the case meetings way back for the 2025 energy code, this was a topic that was discussed. But honestly, at that time, it was like that's way too hard because we need to have some baseline idea of what's going on. Well, now we're getting there. We're starting to figure out what those baselines might need to be and how equipment should work so it can become both a stick of you have to commission your building, But in the end, I mean, who doesn't want to walk into a building, to a grow facility that actually works, right?
Hmm.
Oh my gosh.
And that's one of the biggest complaints, right, that we hear. I mean, we've been doing so much more work in the last couple of years, going on site visits, assessing their climate control, air HVAC system, and helping them improve what they have. And in practically every visit, they complain that they don't have a contractor, that they don't have a service tech, that the contractor disappeared after they installed it, whether that's the controls contractor, the HVAC contractor, the building contractor, doesn't matter, right? Like everyone
Flip the
just
switch and walk away.
exactly, right? And we know that that's happened in commercial and residential buildings too. But for such a complex system that a CEA facility is, I think it does make a lot of sense to have a design review, a commissioning review, and plan, an agent, someone who is there to advocate for you really, and see it all the way through from beginning until and through maybe even the first year of operation.
Exactly. Because
Yeah.
I mean, we're all small business owners in this field, right? And come on, right, Nadia, you
Yeah.
love engineering, you love horticulture. When it's time to balance the books or purchase supplies or hire contractors for your business, you're like, oh yay, I get to spend the night with QuickBook. No, no, because that's not what we love to do. And it's the same thing. I mean, how many people listening to this podcast have actually gone through the trouble of building their own facility? A lot of you have, but you've probably only done it once. So hiring somebody who's gone through the process to help you, to be on your side, to advocate, who understands how to talk to the contractor, who understands the legal language to make them come back and fix the stuff that they didn't install
Yeah.
right, that knows how to test the manufacturer's equipment and make sure it's doing what it's supposed to do. I mean, as a manufacturer, I can tell you, he would love that. We would love to know immediately if that piece of equipment didn't work right out of the box, rather than you struggling with it for a year or two before and going back and forth, finding out only 2 years later that something wasn't right about it right from the start.
Yeah.
We want to know that, and this is becoming standard in so many industries. There's a large retailer that I know, all their distribution facilities, so where the warehouses where they store their goods, they have all these super automated, distribution fork trucks, robots running around. They will run it for almost a year without actually using it, just to practice and make sure that all the bugs
Interesting.
are worked out before they start putting it in actual operation. That's a year of commissioning, but they found that it was worth it to make sure that when they started using it and they relied on it to be there, the building actually worked the way it was
It
supposed
worked on day one,
to.
right?
Right.
I mean, so many people think something's going to work on day one, but
Oh,
experienced growers will take you. It takes, a few harvest cycles. It takes,
exactly.
going through all 4 seasons, or at least three, one shoulder season and then summer and winter, to really work out the kinks and figure out what the settings should be, and how to, manage your growth, manage your
Yeah.
plant's growth, and even sometimes your staff, right? And the equipment and maintenance, and yeah, it's just
Right. And what I hear too often is, Dan, I can't afford that. I have to get it with
I
production.
know.
And like, right, but how many crops? What's the value of a crop? And when you lose 100% of your crop because your building wasn't working right, how can you afford not to?
Yeah, exactly. Exactly. And we know that these crops are valuable. Many of them are. And yeah, I mean, if you say that you lost 100,000 pounds of a product, and put a dollar sign next to that,
Right.
multiply it, and what was the value that you lost, and how much was this commissioning agent or consultant or advocate, right? Probably not the same cost as
Oh,
that first crop, right? I
right.
mean, they pay for themselves in the first crop cycle usually. Yeah. Um well, just so you know, so everybody knows, we are working again with the Energy Commission on developing, proposals and measures for the next code cycle. And one of them is this commissioning and design review process, is how do we instill that so that we have more success and more economic viability, while also making sure that, the energy codes and building codes are implemented, while also meeting, the design criteria and goals of the developer, operator, grower, etc. So for any of those of you who are listening, if you've gone through that kind of process before, we definitely want to hear from you, to hear if you thought that that was a valuable process to go through. So, Dan, let me ask you my final question.
All
Final,
right.
final. Okay. So, after all this talk, distill it down for us. What is energy?
What?
Your head's going to spin
What
off.
is energy? Oh my
Yeah,
goodness.
what is energy?
Okay, I once took a 700 level thermodynamics. It was me and a bunch of PH students, and that was the first question the professor said. She looked at us and said, "What is heat?" And there was 12 of us in the class, so there was about 18 answers, and she's like, "Yeah, those are all right.
Mm-hmm.
None of them are right." I was like, "That's such a philosophical question." I'm like, "Oh my god." So what is energy? I mean, the classic answer is it's the ability to change something, ability to do work, right? To
Mm-hmm.
heat something up, to brighten something with light, to lift it up in the air. You're either overcoming gravity or cold or something like that. Now, I personally would have to go back to my roots. So my undergrad was in nuclear engineering. So at the quantum level, what
Mm.
is energy? It's the quanta. It's the stored little packets of energy that you find in the bonds of molecules of atoms, right? So at the atomic level, it's the energy holding the protons and the neutrons and the electron cloud. And when it's released, it becomes either movement of the atoms, interaction, it becomes heat, it might become light. um, what is energy? I mean, for us it's electricity, it's heat, it's humidity or the lack thereof. Maybe that's the lack of energy. It's
It's
something that
latent
my
energy.
dog has in abundance and I wish I could get. How about, there's your answer. It's something that I really start lacking somewhere around 5 o'clock every day.
Yeah. Yeah. Energy is such a weird word, right? I feel like we
It is.
all innately have a sense or a feeling of what energy is, but when you ask someone to define it, yeah, there's 1,000 different answers, 1,000,000, seven
Right.
billion, probably different answers to what energy is. So yeah,
It's
thanks for
it's
playing.
uh it's the, what is it? What is it in Star Wars? The Force. It's Mito. I can't remember what the word is, but it's the
Ooh, I feel like
Force,
I should
right?
know that.
It's what's flowing through all of us and making
Yes.
everything happen.
And force is another type of energy, isn't it?
Of course.
It's pressure over area.
Another form of energy.
Yeah.
Oh my gosh. I didn't know I was gonna get quizzed at this deep
Everything is
philosophical
energy.
level.
I do have a doctor of philosophy. So, right. I mean,
Okay.
we're ending with the philosophical question.
Oh
Yes.
good.
All right.
We're
You
done. Thank
pass.
God. Okay.
Okay, Dan. So remember how last time we played the game at the very end with rapid fire questions?
Oh geez. Okay.
I have a new set for you.
All right.
Are you ready? Okay, yes or no, single sentence, right? If you want to expand, you can, but they're meant to be quick. Whatever's first that comes to mind. Okay, are you ready?
All right.
Okay, first, what energizes you?
Besides beer. Wait, there's my answer.
Beer. Love it.
A cold beer at the end of the day energizes me to get my work done so I can get to that point.
That's beautiful. Um, how much energy is too much energy?
I'm gonna go back to my dog. The energy she puts out when the UPS driver is coming down the driveway, way too much.
I love that.
Way too much energy.
Simmer down, simmer down.
Exactly.
Is efficiency always a good thing?
No. Wait, can I throw some more on that one?
Yes, I want
It,
you to.
it depends on how you're applying it and those boundary levels again, right?
Mm.
Looking at efficiency at too small of a point means you're doing something really efficient for something that doesn't matter to the greater good.
Ooh, that's deep.
It is. This is recorded, right? I'm going to write that
Yeah.
down later.
Yeah, that was a really good answer. Okay, if you could be any type of energy, what would you be?
Light. I want to be the fastest.
Oh, that's a good, yeah, another good answer. Okay, here's your oddball question.
What?
Like, because
What
that
have these
those were
been?
normal.
Okay, all right, all right.
Okay, and let's see if you get the play on words here. If you were to go on a quest,
Okay.
which would it be? You get it's multiple choice. Okay. Hopefully you get all these references. Would it be Dorothy's quest for the Emerald City, Link's quest for Princess Zelda, or Indiana Jones's quest for the Holy Grail?
Oh, Holy Grail, of course.
Yes.
But, but you know why, right?
Why?
Isn't it the case that Indiana Jones is really completely irrelevant to the movie, had he been in
Yes.
the movie or not? That's kind of feels like sometimes this way I feel.
Hmm. Yeah.
I can
Again,
do
very
whatever I
deep.
want because it's not really going to affect the outcome. So
Yeah.
if I screw it up,
Mm.
that's fine. So I'm just going to do what I want.
We're this teeny tiny and the big, vast universe. Yeah. Who
Exactly.
cares?
But mostly I want to get the Holy Grail because I don't want to follow any yellow brick road and I don't know a cowardly lion and well, I never played that video game.
You
So.
never played Zelda. Oh, I
No,
figured maybe we'd be of the same generation that
I'm
you
an
played
Oregon
Zelda.
Trail kind of guy.
Okay. So you stopped playing video games when you were in the fifth grade.
Pretty much. Pretty much. There wasn't
That's
much
fair.
after that.
Please
But
tell me you got my play on words though.
I got it. I got
Okay,
it.
good.
I got
Okay, excellent. Well, Dan, thank you so much for educating us all on energy codes and standards. Honestly, I really appreciate, and I hope this industry appreciates all the work that you're doing on our behalf and speaking up and reaching out and advocating and just making sure that there's some common sense that is instilled in these codes and standards because that doesn't always happen. And you're all over the place and I appreciate you for that.
Why, thank you. And I just want to say to your audience, keep your ears open. Follow this podcast for announcements of public review comment time, whether it's California, whether it's ASHRAE, whether it's Washington, New York, Canada. I don't care what the state, I don't care what the standard. When there's a public review opportunity available for something in our industry, don't say, Dan's got it. No, no, no. The more voices, the more opinions, the better. So listen to Nadia. She'll tell you when this public review comment periods are open. Go read what's there and give your comment, give your opinion. Let them know whether you think this is something doable or completely irrational.
Yeah, and what we learned from the 2022 energy code cycle in California is that they listened, right? I mean, and they were open to the debate and the discussion and where they started with I don't know, like 8 or 10 measures, right? I mean, it was a long list.
Yes.
Really got whittled down. They really listened to stakeholders about what the thresholds should be, right? So that does the technology even exist? Right? Is this already a standard
Right.
practice? Right? Like all of these things, like they might have said that they wanted a PPE of 5, but that's nonsensical, right?
Right.
But they needed us to tell them what is actually achievable without putting us all out of business. So yeah, speak up, speak up.
Absolutely. The best stuff comes from input from everybody.
Yep. Well, Dan, thank you so much. You might have been guest 3 and 4. We'll
We'll
figure
see what
this out
happens.
with Dana.
Oh, come on, because then I only need one more to get
You're
that
gonna have
number
to tell
5
me what's
smoking
the next
jacket.
topic you want to talk about.
I'll come up
Honestly,
with
a million
something.
things.
something other than energy, though.
Oh, you're right. Okay. How about beer and ice fishing?
There you go. There you
Okay.
go. Very relevant to your audience, I'm guessing.
Maybe, honestly. I mean, with Minnesota, right? Like starting
It's
up
true.
here, I mean, I bet there's a lot of ice fishers in Minnesota.
Oh yeah, oh yeah. I mean, we sit here in Wisconsin and it's legal in Illinois, Minnesota, Michigan. Just I don't know. We're too much of a purple state here in Wisconsin because the Republicans, the Democrats, they both want it. They just don't want the other one to claim credit. So here we sit.
Are you serious?
Yeah.
Ugh, God.
That's about the
People.
only thing I can figure out because they keep proposing, both sides keep proposing, and the other side shoots it down. So,
Interesting.
yeah.
Yeah. All right. Well, we did a pretty good job of not talking too much politics today. So go us. I'm proud of us.
Even though there's so much to talk about.
So much. All right, everybody. Thank you so much for listening, Dan. Thank you so much for being my second or third and fourth guest. And I will talk to you soon.
Bye, everyone.